on an RTX 5090, and you want to mount it vertically behind a glass panel. It is the primary aesthetic goal for almost every high-end PC build today. To make that happen without bottlenecking the hardware, Lian offers the PW-PCI-520X riser cable. The marketing promises you get full PCIe 5.0 data speeds across a 200mm extension. The physics of data transmission tell a different story. PCIe 5.0 requires tight tolerances, and stretching that connection off the motherboard creates immediate instability. This chart maps out the bandwidth jumps across PCIe generations. Doubling the data throughput from Gen 4 to Gen 5 triggers an exponential spike in signal attenuation risk. The data degrades rapidly over distance. In a gaming scenario, that degraded signal causes the GPU to wait for missing data packets. You experience this as microscopic stutters. If the attenuation gets bad enough, the connection drops entirely. The result is a total system lockup, critical WHEA errors, and blue screens. Choosing a Gen 5 riser requires betting that a specific manufacturer's engineering can overcome the physics of data degradation. A standard vertical mount creates a 200mm gap between the primary socket on your motherboard and the contacts on your graphics card. Sending a raw data stream across that distance is like driving out of a city while listening to the radio. The further you get from the source, the more static breaks through the music. Inside a PC case, that static comes from electromagnetic interference. A 1,000-watt power supply and half a dozen spinning fan motors constantly bombard that 200mm route with electrical noise. Any cable attempting to bridge this gap and maintain a Gen 5 connection must use heavy physical shielding and complex electronics to protect the data. Otherwise, heavy gaming loads will force a crash. Riser cables split into two categories to handle this problem: passive construction and active construction. Active cables include a microchip called a redriver. Its only job is to catch a fading signal halfway down the wire and amplify it back to full strength. You can see the mechanism here. The redriver acts as a checkpoint. It reads the incoming degraded data, cleans up the electrical noise, and boosts it back to full strength for the rest of the journey. A passive cable lacks this chip. The signal has to survive the entire 200mm sprint entirely on its own, slowly breaking down into static before it reaches the GPU. Early Gen 5 buyers using passive cables often end up trapped in a cycle of system crashes. The only fix is booting into the motherboard BIOS and manually downgrading the slot to Gen 4 speeds to stabilize the connection. Passive cables generally cost around $70 to $80. Sourcing and installing active redriver chips pushes manufacturing costs significantly higher. Manufacturers rarely list redrivers on their spec sheets. Looking at the official page for the Lian 520X, there's no mention of active components at all. Given the lower price point and missing documentation, you have to treat the Lian 520X as a high-risk passive cable. Until an independent hardware teardown proves otherwise, it cannot guarantee Gen 5 stability. Lian did invest heavily in the mechanical exterior of the 520X. It uses a custom 180 to 90-degree angled connector that wraps tightly around the motherboard. This angle takes the physical tension off the components. Standard straight cables bend aggressively, which pulls on the delicate pins inside the motherboard socket. That proprietary shape locks you into Lian's ecosystem. If you try to use universal third-party vertical brackets from other case makers, this angled header likely won't align with the mounting holes. The ribbon itself is incredibly stiff due to multi-layer metallic shielding. This rigidity is the only physical defense against the electromagnetic interference coming from your fans and power supply. The thick shielding makes wire management frustrating, and the custom angle limits your case options. You have to accept these mechanical compromises to have any chance of keeping the system stable. There is a highly practical alternative to this headache. You can mount your top-tier Gen 5 GPU using a previous generation PCIe 4.0 riser cable. On paper, stepping down to Gen 4 cuts your total mathematical bandwidth pipe directly in half. This chart compares real-world gaming frame rates for an RTX 5090 running on PCIe 5.0 versus PCIe 4.0. Cutting the bandwidth in half translates to a maximum difference of 1 to 3% in actual performance. Buying the older Gen 4 cable instantly keeps $30 to $40 in your wallet. The older Gen 4 standard is incredibly mature. High-quality Gen 4 cables offer a 100% guarantee of signal stability, completely removing the threat of attenuation crashes. Chasing a 1% frame rate increase by using an unverified Gen 5 riser adds massive risk to your build. The older, cheaper standard delivers identical gameplay without the system instability. Early adopter Gen 5 riser cables lacking verified active components remain a stability liability for standard gaming setups. Here is a decision flowchart to figure out exactly what you need. First, are you actually mounting a PCIe 5.0 GPU? If no, buy a Gen 4 riser. If yes, do you demand zero bottlenecks for extreme data workloads? If you only care about gaming, the answer is no, and you should buy a Gen 4 riser. If you truly require full bandwidth, you have to verify the cable. If independent teardowns prove the Lian 520X is active, buy it. If it remains unverified and passive, you have to look at established active competitors like LinkUp. The Lian 520X only makes sense if you're building inside a specific Lian case, running heavy data compute workloads, and are willing to take a gamble on the internal electronics. For normal PC builders and gamers, the path is entirely different. Buy a high-quality, heavily shielded PCIe 4.0 riser cable. You get the exact aesthetic you want for your vertical mount, and you completely bypass the technical failures of Gen 5. Rock-solid, guaranteed stability on a cheaper Gen 4 connection provides better real-world performance than a fragile, theoretical Gen 5 promise.